All right. We're looking at starting our unit with probability here. This is the first stuff we're going to talk about is set notation. Set notation is just really knowing what items we're going to be dealing with as we get into probability. So it's really just counting how many objects, how many items I have in total, and how many I'm interested in, and then that helps me find probabilities of things. So for all of our stuff, we're just going to use numbers, but I mean, honestly, the numbers could be any sort of object that you have. They could be people, um, they could be cards, they could be any of that sort. So, but we're going to use numbers for all of our examples, but just understand we're just counting objects essentially is what we're doing here, okay? All right, so there's a few vocab words that'll come in handy as we do this. One of those things is knowing what a sample space is here. The sample space is just the total objects that I'm looking at or that I'm interested in. Okay, so for this talking point, my example there are 10 values or 10 objects, and I'll just list them: object 1, object 2, object 3, object 4, so on all the way to object 10. Okay, this also with the curly brackets, this is what we call set notation. So that's how we'd list all of our objects in the right notation, so to speak. Okay, and then from there I can have different sets. Okay, so I'll just call this set A. Set A would make up of these 5 objects. Again, object 1, 2, 3, 5, and 8. Set B would just be the 2 objects, and then set C are these 5 objects here. And so we can create different sets from our sample space. If you notice, all these sets come from objects from our sample space. Okay. And then from within there, we start talking about a couple of the different vocab words. These 4 on this side, we want to make intersections, we want to make unions, we want to make complements, and then we want to make subsets from our sets that we have. So let me explain what these are. Intersection. The intersection is like if I'm looking at 2 different sets, I'm looking for the objects that they have in common. So again, the stuff on the left, a lot of times I'm looking at multiple sets, and for intersection, I want to know what they both have, essentially. So this is, I guess, a good way to say this is like what they both have. The symbol for this is just an upside down U. Just looks like this. Okay. And so we could ask the question like, what is in my set A intersection B? So what that's looking for is I'm going to list any object that is in both A and B. It's got to be in both. So 1 is not in B, so I wouldn't list that. 2 isn't, 3 isn't, 5 isn't, but 8 is. So this would just be a 1 object set. That would be my A intersection B right there. Okay, the union, and I don't know. So before we get to union, intersection, both might be, or yeah, I don't know if that word helps, but they have to. It's like the overlap. Maybe that's a better word. Maybe we use the word overlap. Okay. All right. Union is what we have in one or the other. So this is one or the other for this one. And we're going to list any of them. So the symbol for this is the U here. So for example, if I said what is in B, or so let's stay with A union C, I'm going to list anything that's part of A. So that means I'm going to list all these numbers, 1, 2, 3, 5, and 8. And then I'm going to put anything that's part of C. So 2, 4, 6, 8, 10. So, and then I'm just going to put them in order just for the heck of it, but it doesn't matter. So I'm going to put 1. I'm going to put 2. I know 2 is in them both. I don't need to list it twice, though. That's one thing. I don't need to put 2, 2. I just need to put 1 and then 2. 3 is in them, so I've got rid of here, 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 here. 4 is in both of them, or sorry, 4 is in one or the other. It doesn't have to be in both, just one or the other. 5 is, 6 is, 8 is. Again, I don't need to write 8 twice. I just need to write it once. And then the last one would be 10. And so that would be my set right there that makes up 8 objects. So that I've got right there. Okay. All right. So that's how you do unions as well. Okay. The complement is like the opposite. So if I'm interested in, like, if I'm, or not, you could think of it as that, like not. So for example, if I said like A and then I put this little C right here, that's like the complement of A, which what that wants is anything in my sample space that's not part of A. So I would not put 1, 2, 3, 5, or 8. I'd put anything else. So this would be 4. This would be 6. This would be 7. This would be 9, and then this would be 10. Those would be those values that would be the complement. So not part of A. So if I did complement of B, that would be everything but 4 and 8. So quite a few numbers there. And then the last thing is this idea of subsets. What a subset is when, this is just a yes/no question. So these are, like say, these are yes or no questions. For example, if I ask you, is B a subset of A? And the symbol for this is like, it's not a C, but it's like a sideways U is what it is. It's a little bit longer to see. So if I ask you, is B a subset of A, what is that wanting? That just wants to know, is all the objects in B, so 4 and 8, are they part of A? And only 8 is, so the answer to this would be no, that is not true, because not all of them, you have to have every single one of them be part of A. Okay? I'll give you one more example of that. Let's say we did B is B a subset of oops, I already did that one. Not bad. Of C. Let's see, we had C. So we'd ask, is B a subset of C? So what that's saying is, are 4 and 5 part of C, which 4 is, or sorry, 4 and 8, not 4 and 5. 4 and 8 a part of C, and this answer would be yes for this one, because 4 and 8 are both in this one. So it's always the first one has to be part of the second one. Okay, so that's subset for that. Let's just look at all this together. Let's look at, again, all this all the way and see what we've got for this here. Okay, so let's say my sample space is numbers 1 through 14, and then I've got my sets that are defined here. Okay, so for my sample space, I'm going to put it in set notation. That would be sample space is equal to curly Q, and then I'm just going to list them all. 1, 2, 3, 4. I have 14 objects here that I'm going to have in my sample space. Okay, set D is the even numbers that are in my sample space. So that'd be 2, 4, 6, 8, 12, or 10, 12, and 14. Okay, E is the set of odd numbers. So 1, 3, 5, 7, 9, 11, and 13. Set F is the multiples of 4 less than 15. So a multiple of 4 is like anything like 4, 8, that kind of stuff that can be divisible by 4. Or you go 4 times 1, 4 times 2, 4 times 3, 4 times 5, all that kind of stuff. So this would be 4, and it would be 8, and it would be 12, and that would be my sample space there. So that would be set F, and then set G is multiples of 3 less than 15. So 3 would be 1, 6, because 3 times 2 is 6, 9 would be, 12 would be, and that's it, because 15 is outside of my sample space. And then I can ask those same questions that I did on that previous one. First one here, this would be, is F a subset of D? So what I'm looking for is all the objects in F. So 4, 8, and 12, are they part of D? So 4, 8, and 12, this would be a yes question because every single one of them are part of D. This one I want to list D union E. So I want to list all the objects here in set notation. And this one's one or the other, okay? So that means one or the other would be all of these and then all of these. So guys, that's just going to be 1, 2, 3, 4, 5 is in one of them, 6 is in one of them, 7 is in one of them, 8 is in one of them, 9 is in one of them, 10 is in one of them, 11, 12, 13 is, and 14. We'd have our whole sample space for that one. Okay, looking at the intersection here, this would be E intersection G. So remember, that's the overlap of E and G. So I need to see what they have in common. So they both have a 3. I'm going to put a 3 there. No 6 up here, so I can't do that. No 5. They both have a 9. If I look at that. And then that would be it. So it would just be 3 and 9 would be the 2. This next one here, this one's saying what's D complement. So it wants D complement. So remember, that's everything but what's in D. So guys, I've got 2, 4, 6. That means I'm going to put 1. 3 is not. 5 is not. 7 is not. 9 is not. 11 and 13 is not. And then the last one here, sorry, I'm kind of running out of room here. D intersection F. So I want anything that's part of D or F for this one. And D intersection F. So that's going to be the overlap again. So 4 is in both of them, 8 is in both of them, and 12. So that would be all of those, 4, 12, 8, and 12. Okay, and that's what you're looking at with set notation, is being able to write those sets. So this has been your Math Moment with Mommy. Adios.